is there anything that hasn't been talked about? Like anything that's been on the back of your mind, like we need to address this topic before before the end of the day?
Did we talk about TEs really?
That hasn't come up at all, actually.
What about MEV? What happened to MEV?
Well,
Did it go away? Did you
Chris.
solve it and then leave Flashbots? Like something happened.
Chris, we did this incredible thing where we rebranded MEV into Intense. And that's like a magic trick.
Now it's good.
Yes.
But hold up, there's a
good.
different. It is good though, because here's the difference, right? When you're in a cross-chain context, you need to incentivize these off-chain actors to do something, right? Like you do, and so that's your MEV, and it's purposeful. Whereas I feel like in a single-chain context, you're just like eating user funds.
I think it's 100%. Like, I'm sort of tongue-in-cheek saying that we rebranded it, but that was the thing that I was seeking. So maybe like not to just monopolize this fucking panel already, but let me tell like.
Are you the moderator?
I've become the moderator. So the story behind me actually going to start Flashbots was I was trying to solve chain abstraction. I worked on this project over like the summer of 2020. You know, in your presentation you had like summer 2020, like we have a huge scalability problem. And so it was like clear at the time that we were going to start to have multiple different execution layers. And I was like, okay, well, if we have multiple different execution layers, how do we actually create a programming environment for developers that makes it super easy to deploy across multiple different environments? And I built this project that was called Onboard Money. And the tagline was, wrap Ethereum in sexy. And it was Intense before, like Intense were sort of, and chain abstraction before chain abstraction.
Zexy, like the paper, Zexy, or?
No, sexy, like SEXY.
Oh,
yeah.
Damn, okay.
And one of the challenges.
As a gutter, Chris.
One of the challenges that I was looking at is like, how do you actually incentivize third parties to do the execution? And when we started looking at like, okay, there's like these permission sets of meta transaction relayers, and you want to make it permissionless using something like the gas station network that was like popular at the time. What kind of sort of incentive conflicts does that create? And that's where a lot of the work on MEV came from. And my interest with the MEV thing was like, how can I override MEV to be able to do atomic transaction inclusion on the Ethereum blockchain? Because I want to be able to have a swap and call or an approve and transfer from be done atomically on Ethereum without having to modify the EVM. And that was like a lot of the motivation for the Flashbot stuff. And so Flashbot sort of took this turn where we like started to look at MEV being a very negative thing, and it got sort of popular and attention because of it. But it never sort of started to think about like how is MEV used to actually improve the user experience. And I feel like finally we're starting to reapproach this topic of there is a good thing that comes from having these professional solvers who are doing the execution and taking care of all the complexity. It's just that it was never framed in the correct way before.
The negativity was a good narrative.
I mean, it worked for a time, but I think it becomes a hindrance when it starts to scare users away.
Well, I mean, Intense is a rebranding of MEV.
Yes, please.
Not entirely wrong, but Intense come at this from the perspective of the user, right? The user having preferences. And I do think that we've lost, like the MEV perspective had, in my mind, a positive aspect, which is that it was a realization that like we're introducing a bunch of intermediaries again, and users don't have, in practice, a lot of control over them, and users are kind of getting screwed, right? And I think that perspective has been a little bit lost, maybe since you left Flashbots. I don't know the dynamics, but I would like to see some of that again, right? Now that we have a clear idea with Intense and chain abstraction of what it is that users actually want, what kinds of feedback mechanisms do we need to give them the ability to regulate the system and at least keep the actions of operators within some kinds of bounds that the users find acceptable.
What was the perspective that was lost? Sorry?
The perspective that there are entities that don't have users' best interests at heart.
Right. We don't talk much about this. I remember we did the Intense panel at Mev Day in Paris like a couple years ago, and like Vlad was like railing on about like the last thing that you want to do is reveal your intents to like a specialized counterparty, because you just introduce a huge amount of conflict of interest and allow them to give and we don't talk much about this in these systems anymore, right? Where like, actually, what is the role of privacy within these solver networks and intent systems? Maybe you have an opinion on this, that what is being ignored here?
Well, actually, I'll give you an analogy too. Like, so I was like a TradFi market maker at like the evil vampire squid Goldman Sachs, right? And when you think about what actually happened here, and this is sort of Vlad's point. So some central bank calls up, right? Like the central bank of Thailand calls up, and they're like, bid 100 10-year treasuries. They're going to sell you 100 million 10-year treasuries, and that's your price. And you're not supposed to pre-hedge the trade, but like everybody did, right? So they're like selling before they say done. And this is the type of like, okay, you're revealing your intent. And you're getting hurt for it. It's old school MEV, like information leakage here too. The part that I think is worth remembering is like, okay, if you're going to actually transact with somebody with a third party, you got to tell them what you're going to do in some way, shape, and form. But we have all these ridiculously cool technologies to design the mechanisms that optimize that, where you can share exactly what you want to share or what you need to share, and you can design like credible auction mechanisms where the auctioneer can't cheat. And all this stuff is like absurdly cool from a mechanism design perspective, where you can design the right mechanisms that give the user what they want in a way where, I think, Chris, you were saying this earlier, like you just like the user can't get hurt because the system doesn't allow it, right?
When do we get those for intent networks?
I mean, you got to have order flow first, right? Like everything evolves. So there's so many cool, like I want to talk to Ankit about this actually. There's so many cool like.
Sorry, you just got me.
This came, yeah, I'm going to leave in 5 minutes too, so it's like super rude, right? But there's so many cool auction design patterns that are like how we can auction things off. I heard something else about a certain like ZK protocol that's like gonna auction off the right to solve ZK proofs with like yet another auction design mechanism I hadn't heard of before. Like super cool. We get to implement all this like weird economic theory, but the time to do it isn't from day one. It's after you have some order flow that's actually like demonstrating the need to kind of do these innovations, I think, right?
So you wait for the order flow first?
A little bit.
I don't think you wait.
Why even make it
Build the order
non-custodial?
flow.
Like, it's easier to build on Postgres. This is a troll. Okay.
Isn't there something called a Suave? Have you heard of this? Is that going to help?
Never heard of it. Must be something else. Must be an MEV thing.
I mean, I feel like there's a certain irreducibility problem that we haven't talked about a lot, where in order to regulate the system effectively, users must collect some data and take action on it, right? They must collect data about their interactions with different solvers, even different intent-based bridges or other things over time, and see whether or not those solvers are respecting their preferences. Intents at least provide a clear mathematical way for users to express what their preferences are, so solvers like have no excuse for not respecting them. But in order to regulate the system, users need to be monitoring it, right? Or like software which is directly in control of the user.
How much market power do you think market makers will have in the long term? Like, because a lot of the incentive design is predicated on being able to fire the market maker if they're not adhering to the protocol. So do you think they'll be able to push the market around because they're going to have kind of the highest degree of capital efficiency?
Don't you restrict? Shouldn't the protocol restrict what the market maker can do, ideally?
Yeah, but I mean, at the end of
It's
the
a
day-
bargaining power question. Like, what is the bargaining power of users relative to market makers in this if you don't have an alternative?
Well, theoretically infinite, because users control the actual valuable inputs, which are the intents. But they're computationally limited and not online all the time. And in practice, they don't coordinate particularly well on Twitter or wherever this sort of slow game coordination is happening at the moment. So it depends on the mechanism, right? Like if users have wallets that gossip around to each other, what prices everyone is getting from different solvers, and solvers make clear commitments to respect user preferences that can be, that are signed and can be shown if they're violated or something like this. You have a much tighter feedback mechanism. It's like imagine driving a car. Like if you turn the steering wheel, every 10th of a second to adjust where the car is going, you can stay on the road. If you turn the steering wheel every 10 minutes, you're in trouble. Like you're not going to be very good at staying on the road in a car. Same, cybernetics, but same problem, more abstract, but the same kind of time relationship and feedback loops applies.
To maybe touch on one of the, so you mentioned you need to have user volume to have something you can measure so you can start improving it from there. I think one thing that I've been curious about noticing or monitoring as the intent space evolves is reliability. So what is the fill rate of these requests using different kinds of architectures? And Peter, since you haven't talked much yet, I want to point to you to actually give a sense of your experience being an operator in these markets.
Yeah, I think it's definitely a challenge with the if you're going to have thousands of fillers and conduct an auction between them and permissionless entry of fillers, you're most likely going to suffer reliability. So I think that's a big question of how is this going to play out? People are going to submit their orders to some sort of neutral auctioneer. Everyone's going to get a chance, or is it going to kind of look more similar to applications in the same way they choose an RPC provider? And nobody wants to use the decentralized graph. They just want to use the reliable one. They want to use QuickNode. I think that's one of the biggest questions of, will it play out that way, where you kind of have preferred fillers that you work with, they have reputation. If they're no good, you go to the second one, versus fully open distributing. I think it's going to be really hard to be fully open.
I can give some empirical data on this. We did just UX research project where we used all the major intent bridges, just recorded a video and just tried to figure out what was the user experience like. And we were interested in, among other things, the fill rate. So we just did a couple transactions per protocol. And basically, if this is a couple months ago, but if you're using ETH or USDC or kind of a primary asset, fill rates are basically 100%, and then it just drops off precipitously after that. So there is definitely a kind of a coalescence around a couple assets that are serviced, and then nobody else wants to hold anything else.
And is this just because the solvers are willing to hold inventory in those things, whereas other things are not?
Yeah, that's my guess. Yeah.
Yeah. Maybe you have thoughts on this, fill rates?
Yeah, I mean, I just look at it as you need order flow for solvers to, you have a chicken egg problem with solvers, right? So solvers need to have order flow in order to hold inventory on that route. And so where do you have the most order flow? Major assets. I have kind of controversial spicy takes on this, where I'm not sure that bridging long tail assets between chains always makes sense. I think some of those long tail assets might want to just stay on their native chain. But that's kind of an anti-IBC view, I think, Sam.
Well, that's a very pro-across view, I think.
No, it's not an anti-IBC view, because IBC doesn't require that there exists some solver who holds liquidity on the other chain. Maybe it's an anti-IBC compatible across fusion view.
I just think a meme coin to me should live on its meme coin chain, and I don't really see the value of that meme coin being elsewhere. That's I kind of bucket it into okay, you got major assets like ETH and USDC, and they're going to be everywhere, right? And then you have long tail assets, and this is a weakly held view. I don't really know how this shakes out, but long tail assets that don't really have utility elsewhere, they kind of stay on their home chain. And I actually think there's an argument why that makes sense, because you could have an AMM with maximum utility on
OneBalance is trying to give every user their own chain, so this kind of flies in the face. yeah, I'm going to hold my meme coin on my chain because that's my asset ledger.
Yeah, I mean, I just look at it like, again, weakly held view, right? But I'm like, if I have my Frog coin can live on Frog chain, right? I don't think it's like a crazy thought to think of it happening that way. And then there's a set of assets that I think are in between that really make sense to be on many chains. And that's like LRTs and stuff like that are like you want to use as collateral on a lot of things, and those you want to have everywhere. And again, weakly held, I don't know how this will play out. But
Well,
yeah.
I mean, what would make sense to me at least is that there is a supply-demand system here, and holding liquidity as a solver so that you can provide instant fills on other chains has a real cost. And if there's not enough demand to offset that cost, then like no one is going to do it. But this is just, I don't know, it doesn't seem to me like it's intrinsically related to a particular asset. It just has to do with supply demand. If a lot of people want to move their meme coins around because moving their meme coins around is part of their meme coin culture, then they'll do it, and there
Harm
will be
something.
enough, right? But
let me
ETH is a meme coin. It's just a meme coin with particular characteristics.
Don't say that. We love Meath. It's a good meme.
Well, there's a popular ETH on Solana, so you know. But no, I mean, isn't it a UX thing though for users? Like on Solana, if you see today, I mean, people are trading like wrapped wormhole assets, meme coins from Ethereum because the UX is just better and it's faster and cheaper today.
So okay, so let me.
I have to run in a minute too.
You have to run. I will put. So in this distinction of like, will meme coins be bridge? I think like it's a difference to say, will there be multiple chains with AMM liquidity for meme coins versus will you be able to trigger a state update on the canonical ledger of the meme coin from multiple chains? Those are two very, very different things.
Agreed.
Right? Like the latter, I think probably for meme coins, there will be one pool on like some chain, which wherever is like the closest to that ecosystem, maybe in the same cluster where it will be. And then for the others, it would be something else. I want to give a shout out, actually. There's someone in the audience, since Hart is stepping out, you know what's faster than a cross? CCTP. Do you want to come and join us?
Let it be known that Circle does not want to join us.
Come on, it'll be fun. Okay. Anyways, so to come back to what I was saying, so you can have liquidity on multiple different chains, which have liquidity in a single place, but you can still trigger operations from multiple different places. And what that actually looks like is, at least within like the intent framework, you're just giving call data to a solver to go bring to the chain where the token actually lives to do something, and you're paying for that call data execution from anywhere else. And it really doesn't matter what you're using to pay for that call data execution. Is that bridging the token? I don't know. It's certainly executing a asynchronous call across two different execution environments, but it doesn't really require bridging the token itself.
Yeah, I've spoken to one or two L3s that like their main liquidity pool is just going to be on L2, which makes sense to me. And yeah, coming from like a Cosmos perspective, like a lot of liquidity is on Osmosis, so yeah, lives remotely to the asset issuer.
Cool. So we got to this by talking about reliability. Is there anything else with regards to intents and chain abstraction that's sort of like a dark horse not being talked about?
Yeah, I'd be curious. Chris wrote this article called Towards an Intent-Centric Topology last year, where he talked about the end of supply-side block space economics and how, because intents are demand, they force protocols now to compete on services that they can provide for applications rather than just rolling out block space and expecting application developers to build on it.
So, but let me just comment that that is the reason why I'm so excited about OneBalance. It is like a shift in power from a block space oligopoly towards users who can more easily negotiate with these suppliers to be able to get whatever services that they want. So if you reduce the friction to exit from a block space monopoly, you inherently increase the ability for others to come up with alternative solutions to compete with them. And so the marketplace topology and competitive dynamics that are created by chain abstraction and frictionless exit really inherently speed up the fact that you'll have more service chains. But not to steal some of the thunder, I wonder, is there any other implications from sort of that thesis that follow?
I mean, one of them for me, which we have not yet seen play out, but I think we will, is that, as Hart put it, he's left now, but everything becomes a commodity in crypto. All of the services, either they're a commodity or they depend on agreement between users. So, for example, where transactions are ordered is not exactly a commodity because as a user, I need to agree at least on enough say trust domains that I'm willing to order transactions and settle my intents for me with other users, right? So this is not really a commodity relationship and there's some trust involved. But there's no, this like theory that blockchain protocols will act like SaaS companies even when they have a distributed validator operator set and they will somehow, like data availability layers, the idea that data availability is a product that people will pay a premium for is just not grounded in reality. Like it doesn't matter. And you can easily get, 1 of n secure, n minus 1 of n guarantees by storing your data in multiple places, and that's cheap. Like if we look at data availability providers in the real world, such as Amazon Web Services and Backblaze, they're competing on cost. They provide extremely good SLAs, like much better than you will get from a data availability service in crypto. And the people who need to back their data up in multiple places, just do that, and they optimize for distributed edge caching and all this other stuff that we don't. If you ask Dave, I don't know if he's in the audience, but he has some good ideas here on pushing data availability layers in this direction. But I don't think we've really seen that market pressure quite yet. I think we still live in a world where you can, not to name names, but you can start a data availability blockchain and raise a lot of money. And dole it out to people who sort of become politically affiliated with your project. And this may work well as a capital. It may actually work fine. I just would say that it has nothing to do with the provision of data availability. What you've succeeded in doing maybe is building a ecosystem of things that function like political patronage or even token mutual credit relationships. And that's the part that's working. Tying it to the data availability is simply unnecessary. So I think at some point we'll see a capital structure shift where people will no longer view token value capture as necessarily related to the usage of any particular protocol. We have not seen that yet.
So I guess you started this by saying everything is a commodity in crypto. Although today everything is a highly branded.
Right. Tokens are not commodities.
Yeah,
the services are.
I wouldn't agree that everything is commodity personally. I think that there's three kind of financial centers that are not commodities. One is asset issuance, one is time preference, and the other is liquidity. And those are kind of irreducible aspects of financial markets that are not.
What's the time preference piece? Can you explain that?
There's just people who are going to have longer time preferences, that their life is structured such that they can accommodate a long time preference, and that there's going to be a differential between people who have long time preference and short time preference.
Okay, interesting. And then that manifests in the things that they are willing to, they're willing to pay for stuff and their whatever.
Their risk
other
tolerance,
yeah.
that kind of thing.
Okay. So there's these fundamental things that cannot be commoditized, and then there's these other things that we're kind of this should be commoditized, like DA, presumably. So if we sort of try to project out into the next 5-10 years of development, how will this commoditization sort of likely play out? What are the things that we think is valuable today that we will quickly learn are not viable?
Block space.
Block space being the first one?
Block space, execution, storage. Ordering will probably still matter somewhat, but I just think that capital dynamics of tokens and how tokens do in the market has more to do with political affiliations and mutual credit relationships than it does to do with any particular service. By everything will become a commodity, to be clear, I don't mean literally everything. I mean all of the services that we think of chains as providing at the moment and that sometimes we think of as related to value capture.
Cool.
You didn't mention bandwidth.
Right. Well, no one has really seriously tried to build network incentivization protocols, apart from maybe NIM, but I don't know about the details, since the Bitcoin and Red Balloons paper, as far as I know of. So that is bandwidth the commodity. Well, maybe, having access to having the ability to talk to particular nodes in the network in theory is not a commodity because it's restricted. So if I am the only person who can talk to Sam and Sam has a lot of valuable intents, I should probably like be able to capture some value from my ability to talk to Sam. Now, does Sam want me to capture that value? Maybe not. So there's some oppositional dynamics. But on the other hand, if Sam lives in Antarctica on a boat and maybe he's just fine with me capturing the MEV if I do the work of relaying his packets. So yeah, and that's not exactly a commodity, but there's some underlying like physical service that matters here in this case, right? So
Maybe speed and fast finality becomes a commodity. Like right now, when you have roll-ups with 7-day withdrawals, it kind of creates this whole spectrum of token issuers kind of choosing to use OFTs with kind of different security properties, but presumably, yeah, over a long enough time horizon, will shift towards more. Every rollup can be using ZK proofs. That's a bit shorter, so you don't need to use these like intermediate trade-offs. Ethereum might have faster finality, so like, I think these things all start to compress, and the kind of like spectrum of choices and differentiators probably gets commoditized.
This is differentiators between what, like different.
Like if you're a token issuer, do I kind of issue my token on a roll-up, and the only way to get it back to Ethereum today is to wait 7 days? And that's like a rough choice to make, but it's the right choice in terms of like it's the most secure, and so you kind of have people saying, well, let me do an OFT instead. They can kind of move it back faster, but like as the like built-in kind of roll-up bridge gets faster, then there's less of a spectrum of choice. You're getting kind of like that speed for free in a way.
It's going to take me a while to process that one.
maybe another change, at least that I would expect, is that still there's some amount of coupling between protocols and tokens, like SVM, the Solana token, and the Solana programming environment. Or they're not fully coupled. You can get one without the other, but like still in practice, it's easier to get them together. And I think that the friction for making heterogeneous choices there will go down. It already is going down, but it will like go down to a point where, whether or not you use the Solana token and whether or not you use the Solana programming environment, ditto for anything else, will be pretty much decoupled choices.
So I want to pivot a little bit to Peter again. What are your sort of, you've been operating in this game for like a little while, and you've like challenged some of the assumptions that you've had over time, and you've had conversations about like how, you've shifted in understanding of what people actually want relative to like what is sort of the ideal design. I wonder, is there anything that you've sort of learned over this time that you can predict out? Like, there's a lot more attention being paid to like these intent systems, a lot of people designing a lot of these things. What is it that people miss when they start to think about the complexity of these systems?
I think kind of like repeating the point earlier where we talked to a lot of these applications and they want an SLA. And like, if you've got a decentralized filler network, how do you give them an SLA? And like, that is kind of for them.
So, oh boy, do I have the research paper for you. At least so we did some research, if it's okay for me to slightly derail this, just because I think it's a direct answer to your question. We did some research into what was possible with sort of protocol-enforced SLAs and a kind of, are you familiar with rainbow staking, like the Barnaby Minot blog post? Like if you generalize that concept, so you have different kinds of services, and at least in our taxonomy, there are 4 fundamental kinds: ordering, compute, storage, and network packet relay or bandwidth. And you have nodes on the network make commitments. Basically, they make commitments to, given the future messages that they receive, how will they respond? So a storage commitment will look like, if you send me a request for this blob with this hash in the next 30 days, I will respond to 95% of those requests within 100 milliseconds, right? That's an SLA. Now, what you can't do is, you're limited in the degree to which you can enforce this. You can clearly articulate these kinds of commitments, and you can measure whether or not people are performing them, at least subject to having the information about what goes on the network. But you can't force someone to respond to your message. A protocol can't do that. I mean, maybe it still is, in some sense, the legal system provides additional power because it has this like external body who can threaten Amazon if they don't respond to your storage. I mean, this doesn't happen in practice, but in theory, there's a slight difference between these systems. But I still think that there's a lot that can be done just by making these service commitments very explicit and having the measurement, like data collection and measurement and feedback loops for switching service providers be at least like much more automated than they currently are, which is not. Is that interesting for what you're going for?
I think it's interesting. I'm just trying to think through, is every filler kind of committing to an SLA and then like a auctioneer or order flow kind of splitter kind of making that decision around kind of who they give order flow to based on everyone's different SLAs. These are some of the, our learnings where there's these trade-offs in kind of like, an early protocol we designed. We built this like really fancy order flow auction. Many solutions got submitted. You rank them and you pick the best one. And then we kind of simulated it. And it turned out that the incremental gain you got was kind of like less than the gas cost of running that auction and kind of all of these other factors. So I think that's like, like once you're like in the market, kind of like selling it to an app that just like wants it to work 100% of the time, you end up with these like different kind of trade-offs that you go for versus like distributing it across like thousands of fillers and letting them bid on every, especially if you're like relaying a transaction on another chain and like literally paying sub-cent gas. Are you really going to run an auction and have 1,000 kind of fillers bid on it? So I think you're going to end up with these models like, as evil as it sounds, like payment for order flow, where like, like it's like batches of filling at a time. These are the sorts of things we're thinking about.
I'm pretty in favor of SLAs. Like, I really don't mind one filler with somebody who's building a product, like holding their feet to the fire and willing to like kick them out at a moment's notice. Like, as long as that kind of supply chain works and they're really like on top of the person, has a plausible alternative for who can fill, like that's going to work pretty well. You want the whole supply chain to like be accountable to each other, but it's okay. Like, I'm fine with it.
Yeah, I mean, I also think there's sometimes competition is over-indexed on as like a good way to structure a market in the crypto space. Competition in, developing CPUs has this public good of we get better CPUs and we spend more money on, in some sense, like more resources are committed to have multiple companies to build CPUs, but because they're judged on like the speed of their CPUs and the energy consumption, like very clear metrics, we get this sort of development race that produces the public benefit. With solvers competing to match intents, for example, it's like much less clear to me what this is that the public is actually getting out of this. Are we getting like slightly lower latency connections from Chicago to Tokyo? Like, who the fuck cares? Like, do we really want to pay for this? Because someone has to pay for it. If you want to have 1,000 solvers bid on every intent, like that cost goes somewhere. It's not imaginary. They're not going to do it for altruistic reasons because they love competition.
Yeah, I mean, oftentimes the most valuable thing is being able to just like text the person and be like, yo, what the fuck? Like why is this down?
Yeah, that's the slow game.
I have a bunch of other questions to ask on this, but we're out of time. Is there any burning questions in the audience or topic that you want us to cover? All right, let's wrap this up.